Hey, thanks, Ernest. You're right. So, yeah, so I wanted to talk about targeting environments. I had a bit of a uh, problem. I wanted to target piece of code that ran both client and server side. And then I stumbled across I could use features and do conditional compilation to target those. So first use case was using different modules. So as soon as I started to use the different modules, then there's lots more stuff available. Like, so you can start targeting different pieces of hardware and so on. So that's basically how I got into this. I just find it, if you're targeting multiple environments, I found that it was very, very difficult to get a good feedback loop. And also to understand what to use and when to use it. So what I've got for you today is effectively on a plate is the how to take the Rust configuration and the cargo features and how to use them and to get a quick feedback loop as quick as possible. So we're going to dip into a little bit of DevOps work to get the CICD pipeline working. I have got a demo for you. I've got quite a few screens to swap between to sort of help you understand the thought process of going from A to B. And I'll just kick off. Just a bit about me. I'm Max, working in London. Mainly work on sort of payment systems. I've been doing that for many years in the city. So let's get started. On the screen. Okay, cool. So talk a little bit about my use case. So more specifically, if I wanted to run, let's say, Postgres server on the server side, and maybe I wanted to run the same piece of code client side, but use a local database like SQLite or RuxDB, I would look at using the feature flags in my own modules. So what I've done before is made use of other people's modules and brought in using their feature flags. And then I started to think about, okay, how can I use this myself for my own purpose? And there's quite a few advantages of doing that. So some of which to reduce your compile times, to improve the file size. So if you're doing like embedded programming, you'd be very conscious of that. Maybe you want to look at targeting premium features and open features. Maybe you want to have multi-threading as a premium feature of your product. So it adds quite a lot of options when you can conditionally compile your application, so you're in control of the environments it runs in and so on. With that, you also have, you can start targeting hardware and the CPU instruction sets, which is the intrinsics. Like if you really want to add some optimizations. I mean, I've just put this in here for completeness. I'm not doing much work in this area, but I just wanted to cover it just so there's some awareness there. And the obvious targeting is between sort of Unix, Windows, Mac OS, and so on. I mean, with maybe you've got many different types of sort of OS dependencies and you're linking and so on. So you can basically take the conditional compilation really far in terms of like what you use it for. So hopefully by the end of this, you'll understand pretty much how to do it, how to configure it, which is one of the areas that I found most difficult was actually how do you actually leverage the sort of cargo features in your own code using your own modules and stuff. So hopefully I'll sort of enlighten people a little bit on there. So on the code side, it's very flexible. You have the configuration attribute, and you can apply this to any member of your code base. So the first one, I mean, if you can read through here, we've got the single line attribute. We can then conditionally compile the function. or compile like modules or use imports and so on. The idea here is that the compiler decides whether it includes that code or not. So if that feature is not enabled, you will not get that function or that member available to you. So there's quite a few quirky behaviors. If you're managing many dependencies, those dependencies can conflict with each other, and it can be quite difficult to debug. So I've got an example of that, and I'll cover that in a minute when I move on to the demo. There is one gotcha which I found, which is this one, which is using the configuration macro, assuming it does the same thing as the config attribute. This just evaluates to true or false as a Boolean. So the code inside the if statement will still be there. It will still be compiled in. So this is not that useful for reducing compile times, and it's not useful for targeting hardware in any way. So, but it adds flexibility to your code base. So, so that's the code. Next one is to understand how we can configure and compile using these options with the features you've just built in your code base. So ultimately, the first thing that the first thing we want to do is use the Rustc compiler and pass in the config flags for all the different features you want. So in this example, you want to import the feature of SSL. You can do the same thing through a cargo environment variable. You can do the same thing with the feature flags with the cargo build, and you could also configure it inside the cargo toml based on your profile. So not the profile on your target. So if you're building your own features, you need to include them in the. So I'll move my screen down for you. So if you're going to build your own features, you need to include them and list them. And for each feature, you'll have a set of dependencies. Effectively, you don't have to have dependencies if it's your own features, but then you can import different dependencies as you choose. The conditional compilation goes a bit further in this. So if we look at the target dependencies here, we can actually there are a few targets we can apply here, but ultimately, if you're wanting to bring in modules, I'd say for Windows and compared to Mac OS, this is like a really good, a clean way of providing that separation. You need to have the dependency listed here in order to use it within your feature. One of the key parts of the features is you have a default set of features in order for your code to compile at the minimum. You can then list all of the other dependencies as being optional, or all the other features are optional, and you use the feature flags to include those. The dependencies that don't have to be, that you don't want to be compiled, can be set as optional. Those that are compiled by default are set to false on the optional. So and also with the targeting, you can basically set a list of required features depending on whether you're building a binary or a library. So that's on a plate how to set it up, and that will basically compile your binary for you. So the next bit, this is more to then go into the details of how you can target the different architectures or the instruction sets for your CPU. I don't do the intrinsics programming myself. I just want to put it here for completeness, but I just want to show you like how Rust manages all of these features, whether you're targeting hardware, modules, or different operating systems and so on. So this is one area which is very difficult actually to understand and to do. But in terms of how to use the feature, it's the same as everywhere else in the code. So, cool. I have a little demo. It's based off creating a pig and a sheep as both animals. It's very simple to understand. What I'm going to show you step by step is how we take the basic idea, the basic code base, and then how we can chop that up, the different ways we can chop that up based on what I've just shown you. And then we're going to get the feature flags and we're going to pass them through a build pipeline. And hopefully, fingers crossed, my demo will work. So I'm going to attempt to show you the first part. Cool. Okay, so hopefully the font is large enough for you. What I want to do here is just show you an example. This is an example of the Rustc book. This is the animal example where we have a trait called animal, and then we have an implementation of that trait called a sheep. Very simple. The sheep makes a noise. It has it can be seen. It can talk, and so on. The idea here is that we apply the object-oriented design pattern using the traits and implementations in Rust, and that's the way we think about how do we separate our program, not just at runtime but also at compile time. So this was one of the sort of key light bulb moments that you get, is that hold on a minute, all of the patterns that I have, like building a factory pattern, building facades, and all the adapter patterns, you can apply these inside in the compiler using these techniques. So that's pretty cool. So just to give you an example, this is the sheep struct, the animal trait with the constructor and some functions, and here's the implementation of that. And this is implementing the trait code. So in your main function, what we want to do is create a new instance of the sheep called Dolly, and we want the sheep to talk. We want to shear the sheep, and we want it to talk again once it's been shorn. Is it shorn or sheen? So very basic. This is what it does. So just as a prerequisite for what I wanted to show you on how to chop up the code now. So the next idea is that, okay, the next animal we want to have is a pig. We now want to grab the pig. Hold on. Okay, here we go. So now we have a pig called Babe that implements animal. So the idea here is pig effectively implements the same as the animal, but it also has its own functions. So we need some way of using conditional compilation and other random functions to be executed at different parts in our code base as well. So I've put the example of eat for the pig and shear for the sheep. The implementation of which it's a very basic. It's the same example as you just seen, but for pig. It makes a noise, and obviously the more it eats, the more it oinks. We add some extra zeros, and just to give you a view, so we run this and we see the output. Say it goes oink, it eats, and then it oinks some more. What I've got here, because I've done because I'm not using this, I've commented this out. I've now got warnings that it's not used. So I can go the other way and comment out the code that's used on the pig and show you the sheep. So this is now the sheep, the demo from before. So the question is now, how do I compile this so that I either compile for pig or I compile for sheep? And the answer is in number 3. here's the next one. Okay, cool. So, so this is number 3. So now what we've done, we're going to start applying the conditional compilation config attribute with the features for both sheep and for pig. So what we're doing here, we want to compile just for pig, just for sheep. With this, I'm just going to quickly go through the code base again and show you with the conditional compilations that we're compiling either for sheep or for pig or for both. And I'll show you the example when we do for both. And we also have, so I've created an animal factory for choosing whether I'm going to build a pig or build a sheep. That factory will be executed at compile time, not at runtime. So this is the key difference here. So with the sheep, every member has its own config attribute to conditionally compile it. All the implementations as well, they're all conditionally compiled, and so on. So your code base starts to get quite hairy. So in order to execute this, so if we let's see, maybe just if I just run the cargo run. So I've not specified any features, but what I have in my cargo toml is a default to pig. So if we go in here, we have the pig default, and then we have the 2 features specified here. I've not added any dependencies to this, but you can see how that's declared there. And then obviously the use case of that, the use of that is on those attributes. They all match up. So now I want to compile this for sheep specifically. I'm going to show you. So if I run the cargo run command with the feature flag for sheep, we can now compile for sheep. But we've got a problem. So what happens is both sheep and pig implement the same set of functions, and they conflict. You have duplicate definitions. And why is that? In the cargo toml, we have the default, which is pig. So even if you add sheep as a feature, pig will also be compiled. So you get the pig sheep, which is broken. So we then have this extra flag called no default features. So you basically remove anything that's defaulted, and then it's up to you to decide on which feature flags will allow this thing to compile. So, and here we have, this is now the sheep, but the sheep is called Babe as well. So I think this is a theme for a film, maybe. So that's fairly straightforward, I hope, for you to understand. The last part of that is, okay, so now I've got my code compiling based on whether I want a sheep or a pig on the feature flags. I now want to clean up the code. So basically I've got lots of repetition of these config attributes. So to the rescue, we're going to reduce the code down to and use the module. So, and we can import this. This is, again, it's another member that we can just apply the config attribute to, and we can grab the either a pig or a sheep. I think we're close to time, so I'm going to be very, very, very quick. I'm not going to go into the details of the modules, but as you can see, I'm not applying any of the attributes anymore. No conditional compilation in there. It's only done at the root level. So just quickly, we can run this for sheep, run this for pig. That's all cool. So then the last part of this is how do we then stick this into a CI environment? So this is the question mark, which, oh, where have we gone? Okay, so now this is basically the same code base. We've got our main function. It's just now we're starting to wrap in all of the DevOps pipeline parts. So first of all is the Docker file. In the Docker file, how do we get the feature flags through to that Docker file to do conditional compilation? We can pass in the args here, and you can pass as many as you want in. We can set them in the commands to compile. The args can also be set. I think we can move up. Oh, okay. You can basically put them before the from as well, so that flag can actually conditionally compile for the base image. So if you're targeting different environments there, whether it's like all the different versions of Rust, or using muzzle, or whichever you wish, you can do. So that adds flexibility. That gets those feature flags onto the command line. So the next step is like, okay, well, how do I get that Docker file built and deployed? For this demo, I'm using drone. Drone, I'm taking advantage of. Usually drone is with a YAML file, but it's just a static file. With the JSON.NET file, which is supported by drone, they have another plugin for, it's called Starlark, which is like a Python type scripting language. Effectively, we're going to build two sets of pipelines. So I want to target in my build both the pig feature and the sheep feature. And that will effectively put together my pipeline. So my pipeline exists of a test, a build, and a deploy to the target environment. The details of those, I'll just cover the. Let's cover. So basically, the build is ultimately built inside. Is the Docker file from this root directory. I can pass in the build arguments, for the feature flags, and then I can deploy that. What I'm using for deployment is Ansible. So this allows you to basically put in an Ansible playbook. You can specify your hosts in your inventory, like where your targets are, and then any requirements of that playbook. For this one, it's the Docker community collection. You can specify your secrets, which is a private key for SSH onto that server, and then we can pass in extra environment variables, which allow us to specify the type of image. So one of the images is called pig, one of them is called sheep, and that's it for the pipeline. So if I were to go into my code and make some change, so Babe can now go /mu to save this. I'll just quickly commit here, commit push. There we go. Let's quickly push that. So what's happening here? So now it's just kicked off a new build. If I go back to my window, hopefully we start seeing drones. This now kicks off the build, or triggers the build, because that's now pushed to Git. Git has a hook. This will effectively pull the source code using a clone, uses a test. I've not put any tests in here, so that will pass very quick. And then we go through the build process. So in this build, we can see the feature flags that we passed through in order to get Rustc to compile for our specific feature. Keep going. Maybe you want to look at the console logs for drone as well as error handling. So I don't know. So basically, this takes a couple of minutes. I had a problem with my Docker registry, so it's been very slow at the moment. It's not caching. So it should be complete very soon. But ultimately, okay. So one of the things you can see here is that the build arg is being passed in for feature pig for this one. Also, just a note, because we had two different environments we've been targeting, one pig, one sheep. The sheep build is now going on to in parallel. So we can follow the progress of both. This one should, I guess, complete. So we can see here, where are we? Just going down. Okay, so now this is basically pushed to just a private registry called pig latest. Obviously sheep is sheep, and we go into the deployment. This uses Ansible. We get the feedback from Ansible here just to say that, yep, this is a pig, and it oinks, and it's got bar_mu on the end. So we can start using this to, obviously the Docker registry is very slow, so you can use this pipeline to basically speed up your development, get your feedback loop going. This is just a debug log on the deployment. What we can do as well is basically from drone, we can publish messages onto Slack or into Elk, somewhere where you can get alerting in a bit more in a cleaner way than having to go through all these logs. So that is my demo. Nothing went wrong. I did have a bug. I hope nobody saw it. And over to you, Ernest.
Thank you very much, Max. And